Okie dokie. Let's do some calculus. The fundamental theorem. So our book calls the parts of the fundamental theorem the other way around from what I call them. I would say, to my understanding of how the proof goes and what you would really properly call part one, which is like the first part, like the first thing that happens in the proof, is what they call part two. So they're saying here use part one, but obviously this is the kind of thing that we're just using that idea that we need to find an antiderivative and plug the numbers in, and that's what I called part two. So sorry for any confusement there. So let's see. What do you do with this? Well, we find the antiderivative. So antiderivative of x squared. So the reverse power rule is add 1 to the exponent and divide by the new exponent. So add 1 to the exponent and divide. And you can check. I mean, I've been teaching calculus for hundreds of years, and still, it's way easier for me to take derivatives than antiderivatives. So it's just more intuitive, more tattooed onto my brain, whatever. So I'm forever just doing like the quick check backwards, like taking the derivative of these things just really quick as a mental check. Like, did I do that right? Like, does it really go back to here when I take the derivative? So if that makes you happy to do that also, then do it. So let's see. When I plug the 1 in, I get 1/3 minus 3 plus 12. And then when I plug the negative 2 in, I get negative 8/3 minus 12 plus, nope, just kidding, minus 24. I'm going to tell you something crazy. If this was a problem, like a free response problem on the actual AP Calculus test, it won't be. They wouldn't put this on there as a free response. But if it was, you could actually leave the answer like this. You don't have to simplify that. And, you know, there's bigger things in the world to worry about right now, whether or not you simplify this. So I'm really not that stressed out about it. Because of a little tiny bit of obsessive compulsive disorder, or I don't know what, like, it is actually not possible for me to leave it like that. I can't do it. So I'm not going to do it. So this is 1/3 plus 8/3 is 3. And then why I'm doing it like this, I don't know. Well, I guess I spotted that was going to be, those were going to play nice together. So minus 3 plus 12, that's plus 9. And then minus, I've got minus 12, minus 24. So let's see, 12 plus 36, that looks like 48. Let me just flip to the answers here and yield solution manual. Make sure I'm not telling you something that's not true. Anyway, I know how to do calculus there. Hopefully I didn't mess up the math. Oh, it's 48. Oh, yeah. Okay, 11. This is not written in calculus-friendly form. It needs to be written like this. So does the reverse power rule work on this kind of thing? Of course it does. So add 1 to the exponent. That makes it negative 1. And then divide by the new exponent. 4 divided by negative 1 is negative 4. You have to be carefully. You have to be carefully. Did you hear that? It's an ungood combination of words. So plug the 4 in first. I'll tell you what I like to do. When there's a constant here, especially when it's a negative constant, I like to just bring that to the outside and then do my little plugging in game in here. So now that that's gone, that's just 1/4, and that's just 1. Okay, so 1/4 minus 1 is negative 3/4. And times negative 4 is 3. And that is not the correct answer. What did I do? What did I do? Let's let's see. The book claims the answer is 3/4. But, oh, you know what? They're wrong. I wonder if it says that in the back of your book. Sometimes there's a wrong answer in the solution manual, but then the right answer in the back of the actual book. Let me check to see if this is one of those cases. They copied the down. They copied the down. Jeez, English is hard. They have the wrong thing written down as the problem. They have, yeah, you have 3 in the back of your book, so you knew. You were wondering, like, why, Mr. McGrath, going on about this? I have a different solution manual thing that sometimes has the right answers in it. Not for that one. Okay, so 2x times x to the 2x times the square root of x is the same as 2x to the 3/2, and it needs to be written like that. So add 1 to the exponent, and then divide by the new exponent. Dividing by a fraction, same as multiplying by its reciprocal. So I hope you're okay with that. Now that's a constant. I don't need that to be inside here because it's just a constant. So I'm going to do that. And then I'm going to have my 4/5 here. And let's see, what's 9 to the 5/2? Well, the square root of 9 is 3. To the 5th is 243. That's 81 times 3. And then 4 to the 5/2, the square root of 4 is 2. To the 5th is 32. So 243 minus 32 is 211 times 4 is 844. Oh boy, I'm crossing my fingers here. Let's see, 13. Oh, yes. That's it. All right. All the way, like the ways that I'm doing that, I'm just trying to make it as easy as possible for myself. You want to leave your answer like this? Fine. You can't leave it like this because you haven't actually plugged the things in yet. You could leave it like this because the College Board's attitude basically is like if you have something like that's equal, that's the same as the actual answer, how could they mark it wrong? This just isn't done yet, so, but that is. All right, so how about from negative pi over 2 to pi over 2 sine theta d theta. Oh, you know what? Not going to do that because I know what the sine function looks like. And from pi over 2 to there, that's 0. So you can do it if you want and show yourself that it's equal to 0, but I'm not going to. All right, 17. How about from negative pi over 4 to pi over 4 under the cosine function? That is not equal to 0, so I'm going to have to actually do that. You got to be careful with your trig functions doing the antiderivatives. I talked about that some in the notes. So what's the antiderivative of cosine is sine. Right, so what's the derivative of sine? It's cosine, yes. So you just do that backwards check thing real quick. It's a good idea. All right, so what's the sine of pi over 4? I guess we should write out this step. Sine of pi over 4 is the square root of 2 over 2 minus the sine of negative pi over 4 is negative square root of 2 over 2. That's the square root of 2. If you do a problem like that and you get 0 and that doesn't seem, and you're also thinking about what the graph looks like and you're like, wait a minute, you should be thinking about that to kind of check yourself. It would be easy to make a sign mistake here and get 0, but if you think about from here, like the area under the cosine function, which does this from negative pi over 4 to pi over, I mean that cannot be a negative number. So, or 0. So make sure you don't get a negative number or 0. How about the integral from natural log 2 to 3 under the 5 e to the x function. That 5 is just a constant. So what's the antiderivative of e to the x? It's e to the x. If you are your own derivative, then I guess you're your own antiderivative too. So looks like we got e cubed minus, what's e to the natural log 2? What does that mean? Well, I guess natural log 2 is the thing you have to raise e to get 2. So I guess if you raise e to that, you get 2. Right? E and the natural log function are inverses of each other. So if you do e to the natural log 2, they undo each other. You get 2. Also, if you do the natural log of e squared, you get 2. So that's that. I don't see any advantage to taking that further. How are we doing? Oh, this is the last one of this stretch, isn't it? So at this point, did you know that 1 over the square root of 2 is the same thing as square root of 2 over 2? That's a good thing to know, to be able to spot that. At this point, we're really just recognizing, we're doing the reverse power rule, which is super easy to do, and then we're like recognizing antiderivatives. We're saying like, oh, I know the thing that has a derivative of e to the x. We're just kind of spotting them. More rules will be coming. So how about this? Do you know a function that has this as a derivative? I mean, there's not that many things that we know the derivatives of, right? So hopefully you do. So let's see, what's the sine inverse of the square root of 2 over 2 minus the sine inverse of 0? So what this is doing, this is like taking a y-coordinate on the unit circle and it will give you the angle. Of course, it'll give it in radians. So what angle has a sine of square root of 2 over 2? That's in the right domain of the restricted sine function. Got to be able to do that. Know your trig. Okay, so what's about these 55 through 60? I bet this is the other part of the fundamental theorem, don't you think? And in case you didn't know already, the other part of the fundamental theorem, those are officially the easiest calculus problems in the world. It's the most easiest calculus in the world. It really is, because, well, we were just talking about inverses, weren't we? The derivative of an integral, those two things are opposite operations of each other, so they just cancel each other out. A couple little caveats about that, but if this is just a number and this is just a plain old x, then the x just drops in here. It would be wrong to say the answer is sine of t squared, because x is really, this is like that dummy variable. It's like a container waiting for the real show. That's it. That's, I guess, part A of that one. And then part B is just going to be e to the square root of x. Same thing. Because it was from a number, 0, up to just plain old x. What if it's not just a number? What if it's not just plain old x? Well, you know, you've seen the notes. It's really not a big deal. So how about 0 to x, t, 1 plus the square root of t. This is just a number. This is just x. How about, you feel like you've mastered these yet? This is just a number. This is just x. It's the most easiest calculus. Okay, so what about, and we got a little confusement here, potentially. Why? What's wrong with this? The problem with this is these are the wrong way around. But that's okay because I know that if I want these to be the other way around, I can switch them. It just pops a negative sign out, and then it's the right way. I totally, if you're thinking like, oh my goodness, I'm not going to write all out these steps to do this stupidly easy problem. I'm with you, 100%. I'm just writing them out because I'm the teacher. That's it. So it was just dropping it in, but because those are the wrong way around, pop the negative sign out when we flipped it. 58. It's going to be the absolute value of u. They're just kind of playing with u there because just like changing names of variables on u. If you know what I mean, you wouldn't want to get confused about that. So the real show is whatever variable shows up here. It's going to be an x most of the time. Just making sure that we're paying attention. Oh, these are fun. Okay, so what about here if we have this function is equal to the area from 4 to whatever you plug in under the t squared plus 9 dt, whatever that looks like. Okay, and we want to know what is f of 4. Well, if you do f of 4, I mean, this is the f function, so you plug 4 in there. So what's the area from 4 to 4 of, I don't know what, doesn't matter, because if you're just going from 4 to 4, you ain't got no area. How about f prime of 4? Well, the derivative of this, if you take the derivative of this, that just wipes out the integral, right? Derivative of integral, that's this again. So I suppose I should write out first that f prime of x is equal to the square root of x squared plus 9, right? Just like these problems. And then that means f prime of 4 is going to be the square root of 25, which is 5, usually. And then how about f double prime? Well, I guess f double prime, I just need to take the derivative of this. So that thing to the 1/2, that's 1/2 x squared plus 9 to the negative 1/2 times the derivative of what's inside. So f prime of 4 is, let's see, that's 25. The square root of 25 is 5. Negative makes it go in the bottom, so that's 1/10 times 2 times 4 is 8. So 8/10 or 4/5. That's what I'm getting there. Let me just check those and make sure that I didn't tell you anything bad. That looks good. Okay. And then number 60, same game. We got our f of x is equal to the area from the square root of 3 to x under the tangent inverse function. Sorry, started writing x's there, but got to use the t's because x is already doing its thing up here. Okay, so I'll just find the derivative of that. Not that that really involves any finding at all. That just means rewrite it because it wipes this out. Oh, got to check though. Is it just a number up to just x? Yes. I wish that they had more problems in the book that were like the function of x and like maybe an x down here, that kind of thing. But I gave you some of those on that sheet that I made. And then, did you know, I probably have said this in a few other places too, but the fact that the derivative of the tangent inverse function is 1 over 1 plus x squared, that is like the College Board's favorite thing. And of course that means that the antiderivative of this is that. Alright, so let's see. What's f of the square root of 3? That's going to be 0 because you're not going anywhere. What's f prime of the square root of 3? That's tangent inverse square root of 3, and that is pi over 3. How do I know that? Because trigonometry. And then here, what's f double prime of the square root of 3? It's 1/4. And I think that's a good little problem. Those two. Great.